More than 9 decades of serving the nation. Central Board of Irrigation and Power.
Now, so long, we have gone into the calculation through MVA contribution directly. How 3 generators for a fault in the 6.6 kV side of 16 MVA transformer, 35 MVA transformer, 6.6 kV side. How much is the fault current, fault MVA fault current that we have directly derived from the MVA contribution by respective generators and system. System means 2 interconnected 220 kV feeders. Now, we are getting into the topic by getting into the network analysis. How, by means of network analysis, we can calculate the fault current. Fault calculation, how we can calculate. We are considering a condition for a fault in the 6.6 kV side of 16 MVA transformer. I am considering a fault in the 6.6 kV side of 16 MVA transformer. For this fault, for this location of the fault, what are the contributing factors? Let us understand this first. All the 4 generators will be contributing.
Yes, sir.
Some generators will be contributing to the generator transformer of the unit number 1, generator number 1. Some, and then finally to the unit of generator transformer. And generator number 1 will be contributing to the fault through its associated unit of generator transformer UAT. Now, for this purpose, what you need to do? Method is network analysis. That means you have to draw the equivalent circuit of the network. Network means which is fitting the fault. I will draw it. Let us consider this is the source bus and this is the fault bus. Generator number 1. Generator number 1 is the one source. Okay. One source is generator number 1. It is directly feeding the fault through unit of generator transformer UAT.
To 6.6 kV.
Okay. Am I clear that 141 MVA generator is feeding this fellow is feeding the fault like this. So the generator impedance, then this impedance is connected, is contributing to the 6.6 kV fault. Now, how this fellow is contributing? This fellow, the generator is having its own own subtransient reactance through the generator transformer. It is coming like this. Okay? How it looks like? GT. Okay, its own GT. And then that GT is coming through another GT. Then UAT. Then how you draw it? UAT is here. You understand this much, this up to this point or not? Have you understood this?
Yes, sir.
Yes, sir.
Is there any ambiguity?
No, sir.
No ambiguity. Similarly, this is generator number 2. Similarly, other 2 generators will also be contributing. Then how will you represent them?
Significant parallel components.
Through this GT only it has to come. Through this UAT only it has to come. Like that. G, GT. Then similarly, G, GT. Okay. So you have considered all the 4 generators, how it is contributing to the fault in the 6.6 kV side of the unit auxiliary transformer. Now we are still left with one source. That is the interconnected feeders.
220 kV.
220 kV feeders. 2000 MVA.
Net 2000.
Net 2000 MVA. So that fellow will be contributing how? That fellow will be contributing. You see? No, not first UA. This fellow is coming here, then this GT, then this UAT. UAT is common because see, you are computing the fault current at each 6.6 kV side. So all the fault contribution has to pass through the unit auxiliary transformer reactance. It is there. So what will happen? ZS through generator transformer is coming like this. Are you clear up to this point or not? You tell me.
So this ZS is the component of these 2 like net 2000 kV.
Yes, 2000 MVA.
We have considered all that into that ZS.
Okay. Am I clear to you up to this point or not?
Yes, sir.
This is the equivalent circuit of the fault path, fault current path. Am I clear to you or not?
Yes.
Now, what I said earlier, common base. Common base here, what? Because so many MVAs are there, you consider 100 MVA. Let base MVA is equal to 100. Let base MVA is equal to 100. Then ZZ is how much? ZG is how much? You see, generator, whenever you consider, I have earlier said, you consider no other impedance other than subtransient reactance. How much is the subtransient reactance? That is 13.2. Divided by how much is the MVA rating of the generator? 141. Divided by 141. Base MVA is 100.
9.36%.
9.36%. Okay. Is there any ambiguity up to this point? ZGT. Is equal to how much? Z is how much? 12.5. Divided by 140 into 100.
8.92%.
8.92%. Okay. Then threshold. Threshold is equal to how much? 100 divided by base MVA is by 100 divided by 2000 into 100%. Am I clear or not? How much it is?
So it's 5%.
5%. UAT. ZUAT is equal to how much? What is the UAT impedance? 7. 7 divided by 16 into 100. How much it is? How much it is?
43.75.
43.75. Now you replace all these figures with this. How much is it? 9.36. 9.36. 9.36. 9.36. How much is ZS? 5. GT, how much? GT is 8.92. 8.92. 8.92. 8.92. How much is UAT? 43.75. Okay. Is there any ambiguity? Now, this can be, this is all equivalent. These are all identical. So, you can very well compute the equivalent impedance. I am saying impedance, but actually what you are considering is reactance. Okay, because the resistance component is very negative. Is very low. And you see, it does not harm you also. Because this reactance or impedance, this resistance value comes in the denominator. If you neglect something, that is what is happening. Your current level is increasing. That means you
We are in the safe side.
are in the safer side, not safe side. You are in the safer side. So nothing wrong in neglecting the resistance value. Then how much it is? These three series combinations, then series combinations, three series combinations in parallel. How much it will be? How much it is?
13.28 एक branch का आ रहा है
हाँ,
into 13.28 into 3
क्या into 3?
18.
अरे यार, all are equivalent. All are equal. It will be straight away 1/3. क्या? तू कहाँ चलेगा भैया? तो 6 वाले क्या निकाल रहा हो? तुम क्या इक्विवेलेंट से मतलब ये निकालना भी भूल गया तुम?
सर वो सेम है, वो तीनों आइडेंटिकल हो गए।
हाँ, तो क्या होगा?
1/3 हो जाएगा।
हाँ?
0.092 18.28 डिवाइडेड बाय
ये अब ये बेसिक फॉर्मूला क्या है? बेसिक फॉर्मूला क्या है? 1 by
1 by r
Z is equal to 1 by Z1 plus 1 by Z2 plus 1 by Z3. Is it like this? Then is equal to Z1, Z2, Z3. Z2, Z3 plus Z3, Z1 plus Z1, Z2. Is equal to, the Z is equal to, Z1, Z2, Z3 divided by this component. Then all Z1, Z2, Z3 are all equal. That means Z cube divided by 3 Z square. Z square, Z square, Z. The Z by 3. Z by 3, 1/3 of them. All are equal. That is the reason, for the purpose of simplicity, I have kept everything equal. But ideally, all windings have different reactance values. If you want accuracy, you must consider reactance value of each and every machine. Whether it is transformer, whether it is generator, for each and everything, every equipment, you must consider their respective reactance values. But just for simplicity, I have considered them. Have you understood Z by Z?
it's in 6.093.
6.093. Now, can I delete the erase this portion?
Yes, sir. Yes, sir.
The equivalent reactance is 5.765%
कौन सा?
overall, sir.
Now, you see, How much is this equivalent?
6.093.
6.09.
Okay.
I am not considering. And how much is GT? 8.92. 8.92. How much is this one? 9.66. Now, how much is the parallel combination of this? How much? 43.75. How much is this much? This, what is the formula? Parallel combination?
5 into 6.09 by 5 plus 6.09.
Yes. R1 RT divided by R1 plus. Can I delete? Can I erase this portion now?
Yes.
This is the source bus. This is the fault bus. 9.35, 43.75. Then this one, then this one. How much it is? 8.92. Then how much it is coming?
So 2.745%. 2.74.
2.74.
2.74.
2.74. Then what is the equivalent then? 9.35. 43.75. Then this is a series combination. Then how much it is?
11.66.
11.66. Then how much it is? How much it is? Parallel combination?
So 5.18%
5.18.
plus 43.
43 combination. Then how much it is? How much it is?
48.9.
48.9. This is the fault impedance. Okay. Now how much is the fault impedance? How much is the fault impedance? हम लोग फिर से देखना पड़ता है क्यों?
18 kilo ohms.
अरे fault MVA मैं बोल रहा हूँ. Fault impedance निकाल दिया. Fault MVA is equal to
100 by
fault MVA is equal to base MVA divided by fault impedance into 100. Is equal to how much? 100 divided by 48.9 into 100. Is equal to how much?
204.5.
पहले जो निकाला था
Same as sir.
204.5
MVA.
पहले जो फिगर निकाला था एमबीए कैलकुलेटर उससे का है ना
मैं कर रहा हूँ.
मैच का है ना आप देख लो जो दोनों साइड से करने से इतना ये थोड़ा सा प्रोसेस लंबा है
तो इसको हम इक्विवेलेंट में कन्वर्ट कर रहे हैं, कन्वर्ट कर रहे हैं.
और सर ऑन एक्यूरेसी साइड यहाँ पे हमें ज्यादा एक्यूरेट वैल्यूज मिलेगी. हम इंडिविजुअल कैलकुलेशन के पर्पस से
क्या
कर देता है.
ये ठीक लगा हाँ अच्छा
सर फॉल्ट करेंट जो बात नहीं है मतलब
अभी फॉल्ट करंट भी निकाल रहा है तो रिले सेटिंग के लिए तो एमबीए से नहीं होगा ना करंट चाहिए ना तो करंट निकाल क्या देख रहा हो तो पीछे नीचे क्या देख रहा हो
तुम ऐसे देख रहा था.
फॉल्ट